Now we are going to think about this point where the photocurrent is zero position. Here's a figure copy from the previous page. So you could see that at some moment the photocurrent can be zero, or the electrochemical current too. And what is it? It is called the flat band potential, and this could be used for the determination of the Fermi level. Right. So let's think about this. So first, let's think about the band diagram when the energy level is changed by having a contact with solution. Okay. So first, the solution slide, and when the anodic potential is applied, it's like the Schottky contact is formed, and since this is N-type semiconductor, the small drift current you could observe, and if its light is illuminated, a large amount of the drift current is induced. And in case of the cathodic potential is applied, the band is now upward. So something like this. So electrons are coming to the solution side to generate a large amount of current. And in between, here, so at some moment, the Fermi level matched the redox potential of a chemical species. In this case, somehow the band is not changing anymore. So in this case, electron and hole cannot decide which way to go. So the net charge is going to be zero. This is the flat band potential. And what you could notice is at this position, the Fermi level matched with the redox potential of chemical species. That's why you could understand the Fermi level of the electrode. So by using other analytical method, now you could decide the band structure of the electrode, which is quite important to understand the charge processes. So what it is, here's the first, for example, this kind of sample is here. By using the flat band potential, you could understand the Fermi level. And by using the optical method, for example, UV visible absorption spectrum, you could understand this gap because light absorption measures the energy difference between the valence band and the conduction band. So this gives the band gap. And since we don't know the absolute value of the energy without because we don't have any kind of specific zero position. So to do so, we use a node, the balance position by using the photoelectron spectroscopy, which means electron is coming out by using the UV light and measure the motion of energy of electrons, and you could decide exactly the valence band maximum energy. So by using this, you can decide the absolute value of this position, E valence band, and you know the Fermi level, and you know the conduction band, which are the necessary information to understand the band structure of the solid materials. Okay. So with that, in this chapter, we studied the photoelectrode, basics of the photoelectrode process, and how the photo-induced processes are enhanced by light, and so on.